Howdy once again, it's TUBALCAIN at your service, and I'm standing before this little 6 by 18 inch Craftsman Atlas lathe, and you've seen that in several of my videos. And if you haven't watched this one, that's when I buy it and bring it home and all of that, so check that out if you haven't already. But the subject of this video is going to be the repair of the compound on this lathe. And I told you that when I bought this lathe at the auction house, I saw that the compound had been broken out by Mr. Armstrong and repaired by Mr. Hammer and Chisel Mechanic. So I'm going to make a new one, since there's no way I would be able to find a replacement on this. I need to do something about this crank knob here that was made out of Zamek, and for that matter still is made out of Zamek. So this can be removed from the lathe just by loosening these two set screws here. They're Allen head, and it will come right off, and there are two little pins in here, and this is built exactly like the larger 12-inch Atlas lathe, but why wouldn't it be? It would have been designed by the same engineers and just reduced in scale on a Xerox machine. Here it is in 1941, and Hitler had already marched into Poland, but we hadn't been bombed by the Japanese yet. So imagine that, and at that time it was $58.98, and people were just recovering from the Depression, and nobody could afford such a frivolous item. Here's this compound rest sitting on top of the compound rest of the 12-inch ATLAS-Craftsman lathe, and you can see the scale of the two. And also here's the small tool post as opposed to the larger one. Let's go down the basement. This is the operating instructions and parts list for this little Craftsman 6-inch lathe, and there's the model number of the lathe, and this was taken off of vintagemachinery.org. Excellent website, so check that out. But here is the page that is the parts list, and they've got all of the parts reduced onto one page, and it's really just unusable. You know, can you even, there's the or is it right there? You know, so look at the scale of that compared to my fat fingers. Notice how small this tool post is, and that in fact there's just a 3/8 diameter tool bit in there right now, and the regular size Atlas Craftsman, Williams, Armstrong type tool holder won't even begin to fit in here. However, they apparently made a smaller version of the scale down that would fit. But if you look back on the original Sears catalog page, here they show it simply with a 3/8 bit in the tool post, and one bit was included with it. But down here in the accessories there, you can see a selection of the smaller tool holders. No tool holders were available when I bought this. That is, if there were any, they were long gone, long lost. I'm in my basement shop now at my 12-inch more modern Craftsman lathe, the one that was made in 1976, and there was a total redesign someplace there in the early 70s or late 60s of these Atlas lathes. But notice that the compound on this lathe is totally without ornamentation. These, of course, are both cast iron, but the general construction of them is the same. Now, it's interesting to note that these T-slots here seem to be sized with whatever the manufacturer desired. But in the Atlas, not the Atlas, the South Bend How to Run a Lathe book, near the back there's a legend that shows all the dimensions for the different T-slots for the different models of South Bends. But here I have to go strictly by dimensions of this broken compound. Back to the bench. This is probably all irrelevant and immaterial. Doesn't matter either. Back at the bench here now, let's just take a look at what the butcher of Barcelona did to this little compound here. He apparently didn't know that you couldn't weld steel onto cast iron. This is all cast iron. And this had already been broken out, probably long before the rest was broken out. I really don't know. A little bit of damage right here to the corner like you see in a school, but not too bad. So he welded that on there, machined it down a little bit too, it appears, and then welded it on, but you know, that's no good, and there's no strength to it, and it looks terrible. So since I cannot get a replacement part, I'm going to make one. I'll take this apart here just in a second, but I'm going to have to make it out of steel for lack of cast iron, and I certainly don't want it out of aluminum, so I'm just going to make it out of hot roll steel, because that's what I happen to have here on in stock, is what I meant to say. This is my closing 12-inch lathe. Remember that Atlas Closing is the same company, or was, whatever's left of it. I hope it's still around. I know you can still get some parts from them if you can afford them. But notice again here how there's no ornamentation at all on this compound, but yet it is 100% functional. So I plan on making the compound for the little one, no frills, something like this, and I already started a model of this, but that's what it's going to look like, a little bit smaller than this, but essentially just a squared off piece of steel. But that should not be too objectionable, because Closing has used the same design here. Also note that since this lathe came from a school, that the compound corner is pretty well torn up, as there is a huge nick right here from the chuck, and that's very typical of what you'll see in school. And the only reason this isn't much worse is that this was only in service at the school for 12 or 15 years before it was sold and the machine shop closed out and a computer lab installed. I need to disassemble this little compound, and notice that it's really two pieces here or more. So it's the top piece here that I'm going to make, so I need to separate it from the base here. There's the little zero mark or witness mark, and these are the two set screws that push those little pins in there. They have a 45-degree angle on them. I've shown that in a lot of other videos. Notice that there's 4 screws here for the gib, and there is the gib, Miss Georgia Gibb. He used to say, and here she is, ladies and gentlemen, her nibs, Miss Georgia Gibbs, and she was a singer back in the 50s and maybe even before that. So let me take this apart. I'll start by taking these 2 screws out. With the 2 screws removed, the compound will slide right off of the lower piece. A lot of chips in there. And notice that they used a V-thread here, not a Acme thread. This, of course, is Amec, and so is this. Chrome plated, so it looks pretty. They did make the Atlas lathes to look rather pretty with some of the chrome and all of that, and it would have been attractive to a retail buyer rather than industry. This is also cast iron. Now, the purpose of a gib, if I haven't already talked about that, is so that the dovetail does not have to be made super accurately in order to fit the other part. And also that would be a big benefit for them in mass production. Also, we need to compensate for wear over the life of a machine. And these are called machine slides, really. This is a machine slide like you see on the cross slide and on milling machines and so on. So they all employ gibs, and the gib comes out like this, if I can, and there are little set screw holes there for these screws that do the tightening of the gib. Where's my flashlight so you can see in there? So this is the piece that I intend to make out of solid steel. The hard part, of course, is going to be the T-slot, and probably even more difficult is the dovetail. And then we got 2 holes here to drill and 4 holes here. These have to be pretty accurately located in order to line up if I want to line up with this gib. And let's see what else we got here. We got an oiler, a little Gitz oiler, and that's simply to oil the screw. That's all the purpose of that. And this will have to be hollowed out, I don't know, maybe with a ball end mill or what. Probably doesn't have to be a semicircle like this, half round. Just a slot is probably going to be alright to accommodate the screw. In this portion, of course, we have a brass nut, and it's held in place with this set screw and then can be removed. And I may or may not do that, but the purpose of that, of course, is just for assembly and disassembly and manufacture. So this is going to be a several-day job for me. I'm going to start by cleaning everything up, and I think I'll go ahead right now and take out the little gib screws with the lock nuts on them. I'll try to salvage the Gitz oiler. Although just a hole would be good enough too, but you don't really want chips getting in there, but as you can see, chips do get in there. That's also why I preach against using an air hose for cleaning up, because there has to be something that drives the chips up in there, because they don't go up by gravity. One wonders what a guy was thinking when he repaired this, because it's just as crooked as can be when you check it with a square. And you know, I'm wondering how strong that was. Let's just check it here with a hammer real quick. You know, there was just no strength there at all. You can see there was no fusion, and that's where it was broken out. Holy mackerel. I wasn't kidding when I talked about a hammer and chisel mechanic, was I? But now an alternate way of repairing this, and that's still something that I could consider, is to mill this off here, and taking another piece of steel. It could be, and I've seen them compounds repaired this way, perhaps 3 little cap screws here to hold it on each side. I've seen that done many, many times. And oh man, that is a mess, isn't it? But this was done by a desperate man. I spent well over an hour here on my premises looking for a piece of stock suitable to make this. And I had plenty of material that was a little bit too thin, like this 5/8 stock, and I even had a piece that was 3/4, but this requires a stock that's almost an inch thick, perhaps 900 thousandths at this point. So I finally found in my garage a piece of this 12L14. It's a bit rusty, but that's what I'm going to have to use. And you know, within this material lies another compound rest, if only I can release it from its molecular bonds. I was bitterly disappointed. I went to a garage sale the other day and I bought this caliper for 10 bucks. It's brand new. And as you know, SPI stands for Swiss Precision Instrument. So I thought, well, great, I love good Swiss products. You know, they're famous for clocks and all that, and so this is brand new. And I took this out, still got the registration and the calibration and all of that stuff. Oh boy, certificate warranty there. But look at this. And this is the source of my disappointment here, and anger. Actually, a mild amount of anger. This is shockproof. I guess I can drop it. SPI. Ton, 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 ton. The compound is 4 3/4 long. I did clean this up too in solvent. 1 3/4 wide, and at the thickest point, which is right here with the SPI caliper, it is around 900 thousandths thick, and that isn't too critical. So the first thing I'm going to do, and I'll do it off camera, is to cut this stock to length, which will be no easy job. That's a lot of material to saw with my smaller saws, but I do have a worry here. This is cold rolled steel, and you know there's a lot of stresses in cold rolled steel, so when I do cut this in several places and reduce the size of it, there will be stresses in there, and possibly it will change shape on me and bend a little bit. But if it does, I'll have it large enough to where I can dress it on the other side and take it down to dimension. Hopefully it'll be reasonably straight. Alright, let me get started on that. I'll see you in a couple hours when I got that cut. My big Wells bandsaw sure made quick work of that, and it's even semi-square. And I've laid this off here to about 950 thousandths, and now the real job comes of reducing it to that thickness, and that'll be done on the vertical bandsaw, which is quite laborious. See you in a week. I had to stop for a minute to rest my thumbs because that's 20 minutes of sawing with a blade that's really too fine, but I wanted to illustrate something before I finish the cut, and that is, I talked a few moments ago about the stresses in cold drawn or cold rolled steel, and sometimes they even advertise steel as stress relieved or whatever, but there's a lot of stresses in here, just, you know, this going on because it was rolled when it was cold rather than hot. But using my Starrett taper gauge here now, the kerf width at the end here is about 30 or, let's see, 32 thousandths or so. You don't need to see that, but up here the kerf is so much wider at about 60 thousandths. So in other words, this is spread. Shown another way with the caliper here, we have zero it out. The original dimension, zero out, I turned it off. Okay. About 2 inches and 7 thousandths or 5 thousandths there, and on this end 2 inches and 43 thousandths. So it's become larger here than here. And this is the piece I'm going to use, but there'll still be stresses within that and dimensional changes as I go along. I hope that that doesn't haunt me. Alright, I'll finish cutting that now. Is it starting to look like a compound yet? Next thing I'm going to do is take it to the Bridgeport, and I'm going to reduce the thickness here to 900 thousandths, which is what this little casting is. That won't take long. That'll also get rid of all these saw marks. I did mill both sides to clean them up, and that took me down to 900 thousandths thick. Next I will mill it to length. There isn't quite enough there to bother sawing it and then milling it, so I'll just mill that off with a roughing cutter, which won't take very long. I'm down to the correct thickness and length. Now the width on that layout line will take it to the width of the compound, and all 5 edges or surfaces have been machined except for this one, so I'll do that real quickly also with a roughing end mill. Now, after over an hour's work, I finally have a steel blank suitable to make the compound, and it's pretty much exactly the size that I needed. And now I can start the layout and the planning and the cutting, and I have to decide whether I'm going to do the dovetail first or the T-slot. I'm not sure it matters, but let me ponder that for a while.